Welcome back to your last installment of Exploring Spatial Data with ArcPy. In this installment, we are going to talk about how we use describe to describe our GIS data. So we've already talked through looking for what exists in our workspaces or what exists in our folders. We've already talked about making lists of what's in those folders and those workspaces. Now we're going to talk about how do we get into the properties of our individual pieces of data. To do that, we use describe. So describe is a function in the ArcPy module gained through arcpy.describe. Describe really can just be thought of the way that you're going to access all of your data set properties. So if you were in a desktop GIS software, you were to right click on the data set and go down to properties where you'd see the name of the data set, where it lives on disk, the spatial reference, the units. All of those things are going to be what you have access to within describe within ArcPy. So for example, the list here, your spatial reference, field names and definitions, the shape, the extent, the directory path where the data set is stored, all of those can be found on describe. So what describe returns, so remember functions always return something. So this is why we learned about functions in the beginning of the semester. What the describe function returns is called the describe object. And that object contains various properties that we can gain access to about the item that was described. So for our feature classes, some common properties, and if you look up the describe object online, you'll see an entire long list, multi-page list of all of the available properties off of the describe object. And I don't want to show that to you and get you overwhelmed, because really in the field of geospatial applications, we really focus on 4 of these describe properties. The one being base name, and that's the name of your data without the file extension. So think of a shapefile called bikes.shape. The base name would be bikes. The catalog path, that is the full path to your data on disk, starting all the way back at the drive letter. The data type is going to tell you the type of data, and the path is going to be the file path to where your data set is sitting. So here's a screenshot of what that looks like with some data that you've already seen in these Exploring Spatial Data slides. We have, of course, imported ArcPy. We've set our workspace to be our My Data folder. And you can see here that I have left on here the fact that I've listed my feature classes with the wildcard of the W, and that's what I have listed here. So what I'm going to do here is I'm going to set up a describe object to work off of my water, pond, lake, poly shapefile. Now, this here, having access to this shapefile right here, has nothing to do with the fact that I've created a list above. It has everything to do with the fact that this shapefile lives in this workspace. So describe is going to give you access to any feature class that is inside of the workspace that your script is sitting in. So we're going to call the describe function. Now notice we're using another on-the-fly defined variable. This variable called DESC, which is just a common variable name for the describe object, is going to store the describe object that's returned by describe. And describe doesn't have any required parameters except for the fact that you need to describe something. So here we're going to put the name of a data set that we know lives in this workspace. After we've populated the DESC variable with the describe object, we're going to call different properties of this describe object. One being the base name. So notice we're just going to do that. And the easy way to see it is to put it in a print statement, right? So that way it prints out to you. So we're going to print the base name. Notice how it strips off the .shp. We're going to print out the catalog path. Notice how that sits there, the full catalog path, including the data set name. We're going to describe the data type. It tells us it's a shapefile, right? If we had a geodatabase feature class, it would tell us geodatabase feature class. If we had a raster data set, it would tell us that we had a raster data set. And here we're going to print the path. And here I just want to point out the difference between catalog path and path. Path is going to give you the string leading up to your data set name. So basically the workspace where it lives. This is the folder or the geodatabase that your data set lives in. The catalog path gives you the string that includes the data set name. Those are just good to keep in mind, because if you need to, for instance, populate a variable with some of this information, this is how you would gain access to it. So instead of putting a print statement here, you could just define a variable. Let's say we wanted to call a variable that was just data path. We could say data path is equal to DESC.catalog path. And that would give us our full pathway to the data set, including the data set. So we can print them out, and that's nice to look at them to see what they are, but you can always capture these properties within a variable by just putting a variable name to the left and saying equal, and then setting it up here to grab that property off of your describe object. All right, so those are important things that are on the describe object. The describe object in geospatial applications is also often used with the spatial reference object. So the spatial reference behaves a little bit different than our other properties when it comes to describe. So it is its own object, but it's accessed using the describe spatial reference property. You'll often see SR as a common variable that's used to capture this object properties, but it could be anything out there. I just wanted to point out that if you see SR, and you will see that in the Esri help documentation, that SR is just a common variable that's defined on the fly to store the spatial reference object. So for feature classes, common spatial reference properties are going to be the name, that's the name of the spatial reference, the projection name, the name of the actual, just the projection, not the datum, just the projection, the datum name, which is the name of the datum. Keep in mind that the name of the datum can only be pulled off of the spatial reference object for data sets that are in geographic. I do not know why, but with the spatial reference object, if you have a data set that is in a projected coordinate system, you cannot isolate datum name off of the spatial reference object. We'll talk about how that plays out a little bit later in the semester, but that is one nuance to be aware of. Because we know it has a datum, but for some reason on the spatial reference object, we cannot access it. The type, and that's going to tell you whether you're a geographic coordinate system or a projected coordinate system. And then the factory code, that's also known as the well-known ID, the WK ID. And that's the unique code of the spatial reference that is used in the world of geospatial globally. In a specific outside of software. So this was an effort for all of the spatial references that all of our worldwide geospatial data is in a variety of places to give them unique ID codes that could be used without having to know the name or the spelling. So all of our spatial references within the Esri software have a well-known ID or a factory code that is actually a number that would transfer to other softwares or other open source programs as well. So here's just an example here. I am still working off of describing that same water, pond, lake, poly data set. I've described it. I've put the describe object into a variable called DESC. Notice how I'm going to call, though, the spatial reference object from the describe object. So I'm just going to set up a variable on the fly called SR. I'm going to set it equal to the spatial reference object on the describe object. So the difference here is that it's kind of a nuance, but spatial reference is not a property of the describe object. Their spatial reference object is its own object, and it has its own individual properties that we can grab off of it, right? So there's other things attached to it that we can grab. And we're just going to look on this example. We're just going to print those things out so we can see what they are. We're going to print the spatial reference, the name property, and that's going to give you the whole string that you're used to seeing in the desktop software, right? So this is the string of the spatial reference that includes the datum name, the projected coordinate system name, and typically also the units. Now remember, this is just a long string that is actually the name of a text file on disk that in that text file has all of the parameters associated with this coordinate system and with this spatial reference. So that's the narrative of that name. We're then just going to print the projection name. So notice here it's printing out Lambert conformal conic because remember, state plane coordinate systems in the United States are built off of a particular projection. So in Ohio, because of the orientation of our state, we are built off of Lambert conformal conic. So that's isolating just the projection name. And here I went through and I showed you that I'm going to try and print out the datum name. And it prints nothing. It doesn't print an error message, it just prints empty. And that's because we are in a projected coordinate system. And for some reason off of the spatial reference object, we cannot isolate the datum name. But if you ever need to know it, you can just print out the spatial reference name property on the spatial reference object, and it's going to include the datum for you at the beginning. If I'm going to look at the type of coordinate system I have, remember it's going to either be projected or geographic. It's telling me I'm in a projected coordinate system, which is important to know. And if I ever need to know the factory code or that WKID, it will tell me here what that WKID is. So those are some ways that we can gain access two things off of the describe object. The things that describe our data, describe what it is, where it is, what type of feature it is, and also describe the spatial reference and the elements within the spatial reference. All right, so on to your other activities and best wishes.